లక్ష్మీకాంత్ సార్. సార్ అన్మ్యూట్ చేసి మాట్లాడండి సార్. లక్ష్మీకాంత్ సార్. లక్ష్మీకాంత్ సార్.
Yes, sir. Can you hear me, sir? Hello, sir. Can you hear? వినపడుతుందా సార్?
ఓకే సార్.
అదే
పేరు వచ్చారో లేదా ఎవరన్నా వచ్చారో మళ్ళీ ప్రాబ్లం.
సరే సార్. అవును. ఎస్ సార్. ఎస్ సార్, నేనే సార్.
ఓకే ఓకే
ఓకే ఓకే. Okay, okay. Thank you, sir. Shall I start, sir? Shall I start, sir?
Okay. Sir. Okay, sir.
Okay, sir. Thank you.
Okay, sir. You can start the class.
Okay, sir. Okay, Nana. Good evening, everyone. Okay, I welcome you all to the math session 4. So this is 4th day. So now in the previous class we have learnt about related HCM LCF related problems and few problems related to division algorithm. Okay, so now in this session we are going to learn about base system. So what is mean by base system? First let us try to understand base system. Now in this session we are going to learn about base system. What is mean by base system? See, first let us understand. See, whatever the numbers, digits we are using, that is a decimal number system. See, the number system which we are using, that is a decimal number system. So decimal number system means, so in this one base is 10. So in this system base is 10. See, for example, you take any number, let us say some number 542. So now 542 means what? This is the number base 10 system. So what we are using base 10 system, this is the base 10, we'll write. So now what we do here, 1 minute. So now in this system, see base system. So 542. See, 542 means how can we write this one? This one we can write it as 5 into 100 plus 4 into 10 plus 2. So this is the base system, right? So when we write 542, what are the place values of this number? So two place value, we say unit digit 10 power 0 and 4 is a tens place, 10 power 1 and 5 is a thousands place, so hundreds place, so 10 square. So we write like this. You take any number. So you take any number. See, let us say for example, if we take 2345, let us say. So how can we write 2345? So we can write what are the place values of this number. So this is 10 power 0, this is 10 power 1, this is 10 square, and this is 10 power 3. So this 2345 can be written as 2 times 10 power 3 plus 3 times 10 square plus 4 times 10 power 1 plus 5. So this is how we can write it, right? Now, so this is how we can write it. So now this is how we can write it. So 2 into 10 power 3. So 3 into 10 square, 4 into 10 like this. So this is a decimal number system. So why? Because the base is 10. So when we use a decimal number system, what are the digits we use generally? See, the digits which we use generally, they are from 1, 2, 3, 4, right? 5, 6, 7, 8, and 9. So these are the digits only we use in decimal number system. We don't use any other number other than this. So this is a decimal number system where the base is 10, and we take digits from 0 to 9. Now, in this session, we are going to learn about with different bases. See, whatever we know so far, that is only decimal number system. Now, in this session, we are going to check with the different bases. See, the minimum base we will take 2 onwards. So, see, for example, you take any base. So how do we write generally? So the general base system. So you take any number, let us say the general base system. So general base system. So how do we take this general base system? So we can write, you take n digit number. Let us say an minus 1, an minus 2, and so on up to a3, a2, a1, a0 you take. So this is a how many digits here? N plus 1 digits are there. See, from n to 0, this is a n plus 1 digit number. So this is an n plus 1 digit number, right? So how do we write? Let us say this base is b. Now what are the place values of a0? A0 place value is b power 0. If the base is 10, we write 10 power 0, 10 power 1, 10 power 2, and so on. So here the base is b. Now the place value of a1 can be written as b to the power 1. Place value of a2 can be written as b to the power 2. Place value of a3 can be written as b power 3. And so on. The place value of, so this one, we can write it as b power n minus 2, and so on. What is the place value of bn, an? So this is b power n. So we can write like this. See how we write in the decimal number system, same way. See, we have taken, let us say 5432 base 10. So how do we write this one? We write this number as 5 into 10 power 3. So why 10 power 3? This base is 10 power 3. Now what about this? 10 square. This is 10 power 1. This is 10 power 0. Right? Now you can write this one as 5 into 10 power 3, 4 into 10 square, plus 3 into 10, plus 2 into 10 power 0. So 10 power 0 is nothing but 1. So we can write this one as like this. Now with any different bases, any base, for example, when the base b is given, what are the place values? B power 0, b power 1, b square, b power 3, and so on up to b to the power n. So now see, generally the base, see now the base, see when we take the base as 10, what are the digits we are going to get in the number? So the digits from 0. So if you divide any number by 10, the remainders are 0 to 9. So 0, 1, 2, 3, 4, and so on up to 9. So similarly, when the base is 10, so we are getting digits from 0 to 9. When the base is 2, see when the base is 2, you divide any number by 2, you are going to get digits as 0 and 1 only. See, if the base is 3, we can write this, the digits are 0, 1, 2. If the base is 4, so we can take it as 0, 1, 2, 3. If the base is 5, we can write digits are 0, 1, 2, 3, and 4. Okay, these are the valid. When the base is 10, digits from 0 to 9. When the base is 2, 0 and 1. See, if the base is 2, that system we call it as binary number system. See, the computer cannot understand decimal number system. It can understand only binary number system. Okay. So now, so what we do here now, when the, see when the base is, see when the base is 8, when the base is 8, this number we call it as octal number system. Now what are the digits from this? 1, 2, 3, and so on up to 7. See, like this we can write. See, for example, when you can take base 10, 11, 12, and so on. See, maximum we will take 16. See, when the base is 16, this decimal number system, this number system we call it as hexadecimal number system. So this system we call it as hexadecimal system. Okay. Now when you divide any number by 16, when you divide any number by 16, So when you divide any number by 16, what are the remainders you will get? You are going to get remainders are 0, 1, 2, 3, 4, and so on. Up to 9 will write. See, now here the number you are going to get 10. So 10, 11, 12, 13, 14, 15. These are the remainders possible. So now here the problem is if you write digit as 10, we cannot identify whether the digit is 1, 0 or 10. See, we need to show the difference of 0, 1, 10, 0 here. See, look at here, 11 is given. So when you write 1, 1, we may think that 1, 1 is 2 digits, but actually 1, 1 is what? 1, 1 is only 1 digit, right? See, when you divide a number by 16, the possible remainders from 0 to 15. So what should we do here? We have to show the difference. See, for example, if the remainder is 13. So 1 and 3 also here, right? 1 and 3 also here. So when you get a number 1, 3 like this, you cannot identify whether this is 1, 3 or 13. We cannot identify. So due to this reason, we are going to give some alphabet symbols. So 10 will be identified as A. So whenever you come across a number A, what does that mean? That means A is nothing but 10. So in this number system, whenever you come across A, that is nothing but 10. B is nothing but 11. C is nothing but 12. D is nothing but 13. E is nothing but 14. F is nothing but 15. So we can write like this. So hope it is clear. So next here, see now we are going to see the examples and we will solve the problems. So binary to decimal and decimal to binary. Okay. See, let us take one small example. See, let us convert decimal to binary. How to convert from decimal to binary? See, the decimal to binary, how to convert a number. Okay. Now I am going to take one example. So convert, let us say 45. 45 base 10. So this indicates base 10. This is a decimal number system. Convert 45 base 10 to binary system, binary number system. Binary number. So binary means what? Binary is nothing but what? Binary is nothing but base 2. So the number, binary number is nothing but base 2 system. So now whatever the number they have given, this number is in base 10. This is decimal number system. How to convert into binary number system? So you have to divide this number by 2. So let us divide here this number by 2. So what you are going to get? So the remainders you should write here. Now 2 times 22, right? What is the remainder here? 1. Next, 2 times 11. What is the remainder? So this is 0. Next, 2 times 5, 10. So remainder is 1. So 2 times 2. What is the remainder here? 1. So until we get 0 and 1, we should write. Now 2 times 1, 2, right? So here the remainder is 0. Now here you have to write the numbers from bottom to top. So you need to write the numbers from bottom to top. Like this you need to write. Okay. So you need to write the numbers from bottom to top. So what we can say from this? You can say from this, these numbers 45 base 10 is equal to, what is the binary number we got? 101101. 101101. So this is in base 2 system. So 45 in decimal number system can be written as 101101 in binary number system. Hope it is clear. See, whether it is correct or not, we can verify. See, in mathematics, we can verify our answers, whether it is correct or not, most of the times. So now let us convert from binary to decimal. How to convert from binary to decimal? See, this is the number they gave. See, 101101 we got. So what is the base of this number? Is it 2? Now here the base is 2. So here the base is 2. Now how can we write here? So now here the base is 2. Now what are the here values? See here the base is 2 means, now what are the place values of this? Is it 2 power 0? So is it 2 power 1? So is it 2 power 2? So is it 2 power 3? Is it 2 power 4? Is it 2 power 5? See, you should multiply and add to convert this, right? See, what are the place value of this one? 2 power 5. So I can write 2 power 5 into 1 plus 2 power 4 into 0 plus 2 power 3 into 1 plus 2 square into 1 plus 2 power 1 into 0 plus 2 power 0 into 1. See, now add this. 2 power 5 is 32 plus 16 into 0, that is 0. Now this is 8 plus 4 plus 0 plus 1. See, 32 plus 8, 40, 44, 44 plus 1, 45. See, now we have converted this decimal number to base 10. So hope it is clear for everyone. See, now this is base 10. So this is base 10. See, now this is how we can verify. So you need to divide like this. You have to write the remainders from bottom to top. So from bottom to top, you need to write the numbers. See, let us take one more example to understand better. So convert. Let us take some other number. So 38 base 10. So 38 base 10 to binary number. So binary number. So what you need to do? So you have to divide. You have to divide by 2. Any number you have to divide by 2. Now let us divide this 38 by 2. What do you get here? 38. 2 times 19. 38. So what is the remainder now? Is the remainder 0? So 2 times 19. So remainder is 0. Now what about here? 2 times 9. What is this? Is it 18? Remainder is 1. Again you divide by 2. What is the remainder here? 2 times 4, 8. Remainder is 1. Again divide by this. 2 times 2, 4. Remainder is 0. Again divide by 2. 2 times 1, 2. The remainder is 0. Now how can we write this one? 38 in base 10 can be written as. So from the bottom you write 100,110 base 2. So we can also verify, right? So how to verify? Convert now binary to decimal. So you can convert from binary to decimal. So how can we convert now here binary to decimal? So you can write this one as place values. 2 power 0, 2 power 1, 2 square. So this is 2 power 3. Like this we'll write. So now let us write here. So 100,110. So base 2, right? What are the place values? This is 2 power 0 is nothing but 1. I'm going to write here. 2 power 0 is nothing but 1. Now this is 2. This is 4. This is 8. This is 16. And then this is 30. So multiply here. 32 plus 4 plus 2. So is it 38? Now this is how we can verify our answers. Okay. So hope it is clear. Now see, every time when you get this, so we need to do like this. Now here we need to understand one logic here. Here we need to understand one logic. See, for example, you have a base 2 system is given. So base 2 system is nothing but what are the place values? See, base 2 system is nothing but what are the place values? 1, 2, 4, 8, 16, 32. These are the place values we'll get. See, when you observe this, what is 1 plus 2 sum? So is it 3? 3 is nothing but what? Is it 4 minus 1? See, 1 less than this, right? Now what about these 3 numbers sum? So is it 7? 1 less than this? Look at here. Next, you take the sum of 4 numbers. What is the sum of this? Is it 15? Now you take the sum of these 4 numbers. What is the sum? Is it 31? See, 1 less than 31. So You need to know this logic. So what is this? See, you can take 1. 1 is nothing but what? 2 power 1 minus 1. Okay, now 1 plus 2. 1 plus 2 is what? What is the next number? 2 square, right? 2 square minus 1. 1 plus 2 plus 4. Look at here. 1 plus 2 plus 4. So what will be the next power? 2 power 3, right? 2 power 3 minus 1. You can take 1 plus 2 plus 4 plus 8. 8 is nothing but 2 power 3, right? So this is equal to 2 power 4 minus 1. So 1 plus 2 plus 4 plus 8 plus 16. What is this number? 2 power 5 minus 1. So this is how you can write. Now by using this logic, we can easily write the binary numbers. See, let us say for example, see now just now we have taken examples, right? So convert 45 base 10 to binary number. So we are going to convert into what number? Binary number. So now first write the place values. What are the place values of 2? 2 power 0, 1. I am going to write the values here. So 2 power 0. 2 power 0 is nothing but 1. So let me write here 2 power 0, 2 power 1, 2 square, 2 power 3, 2 power 4, 2 power 5, 2 power 6. So now what is this values now? So here now you can think here. So what is 2 power 0? 1, 2, 2, this is 4, this is 8, this is 16, this is 32, 64. Now we are converting 45 to binary number. See, you can also divide. See, by using division method also we can find out that we have learnt already. Now here, look at here, 45, right? Look at here, this is 64. This is not necessary because 45. Now 45 means 32 is needed, right? So here you should put 1. See, 45 means 32 is needed. So 45 minus 32 is how much? 13. 13 more is required, right? We need 13 more. So 16 is not necessary. You can put 0 here. Hope it is clear. See, 45 is a decimal number. We are going to convert into binary number. So now what we have done is we have written this place values, exponents of 2, 1, 2, 4. So we have written the place values 1, 2, 4, 8, 16, 32. So when you write 45 base 10 into binary number, now 64 is not necessary. We need 32. So if I take 32 means 1, 32 into 1, right? How much more is required? 45 minus 32. So 13 more is required. So then 13 more is required means 16 is not necessary. So you should put 0 here. Now look at here 13. Now 13 means what? Now 8 is required, right? So 13 minus 8, 5. So put 1 before under 8 because 1 is needed. 1. Now when you put 32 plus 8, how much? 40. So still 5 more required. 5 is needed. So 5 means what? 4 is necessary. 1. Now when you remove 5 minus 4, what? 1 is needed. So 2 is not necessary. So you can put 0 here. You can put 0. So 1 0 1 0 0 1. So this is how you can convert 45 into base 10. So hope it is clear for you. So I'll give you some more examples to understand better. See, now just now we have taken 38. So convert 38 base 10 to binary number. Okay, binary number. So what you need to do here, you write the place values of 2. So what are the place values of 2? 1 2 4 8 16. So now I am going to write here 1 2 4 8 16. See, now let us write here 1 2 4 8 16 and 32. See, 64 is not necessary because 64 is greater than 38. So we need 32. So put 1 here. So what is the difference? 38 minus 32, how much? 6. So we need additionally we need 6 more. So you have to put 0 here because 16 is not required and 8 also not required because we want only 6. No need 8. Now 6 means 4 is needed. You should put 1 here. Now 6 minus 4 how much? 2. So 2 is required. You should put 1 here. So here you should put 0. So like this we can easily solve for any number. So if you take division also you can do, but it will take time. So this is how you can solve. See, let us take example. If I take number 100, see 100, I have to convert into binary number. Binary number. So what we do? So we have to write the place values of 2. 1, 2, 4, 8, 16, 32, 64. See, next 128 will come. This is not required. 64 is needed. Now, what is 100 minus 64? 36, right? 100 minus 64 is 36, right? Now, 64 is needed. 32 is also needed because 36, right? So, 1. So, 36 minus 32, how much? 4. 4 means 16 is not required, 18 is not required, and 4 is required. So, put 1 here. Now, 2 is not required, put 0. 1 is also not required, put 0. So, what is the binary number? So, you can write that binary number is what? 1100 100. So base 2. So you can write like this. So hope it is clear. See next, we have already learned the sum here. So what is the sum? So we have seen from this, we'll see. See, for example, you are taking as a sum like this. See 1, 2, 4, 8, 16, 32. So we have already learned. See, what is the sum of 1 and 2? Just 1 less than 4. So this sum is 3, right? So what about this total sum? This sum is 7, 1 less than 8. What about this total sum? 16 minus 1. This is 15. 1 plus 2 plus 4 plus 8, 15. Now 1 plus 2 plus 1 plus 2 plus 4 plus 8 plus 16. See, this total sum is 31. Now look at here, this total sum. This total sum is what? 63. See, because next number is 64, the sum of all this number will be 1 less than that. Okay. Hope you understood this logic. So here now by using this also we can write if the number is nearer to perfect squares, powers of 2. For example, convert 125 base 10 to binary number. Binary number is given. Binary number. So what you can do here, binary number. So you write the place values. What are the place values? We write 1, 2, 4, 8, 16, 32, 64. Next number 128. 128 is not necessary. But we know that sum of all these numbers is how much? Sum of all these numbers is just 1 less than 128, right? This total sum is 128. Next number 128 minus 1, 127 you will get. Or 2 power 6 is 64, right? This is equal to 2 power 7 minus 1. So this is 127. See now, hope you understood. 1, 2. See 1, 2 means what? 2 square minus 1. 1, 2, 4. 1 plus 2 plus 4 is 2 cube minus 1. 1 plus 2 plus 4 plus 8. 2 power 4 minus 1. Like this. Now 62, 16, 32, 64. Now we know that this total sum is what? This total sum is how much? This total sum is 127. So 127 means what is not required here? 2 is not necessary, right? Now remaining all is needed. See, even if you add now here, you will get answer 127. See, 64, 32, 16, 8, 4, 1. You add this. 4 plus 2, 6, 12, 20, 24, 25. Right? Now, what about this? 6 plus 3, 9, 10, 12, 125. So, this number is what? This is 125 in base 10. Because 127 means all are ones. All are ones. So, this is how we can write. See now, let us understand how to write numbers. in this binary number. See, now let us take example. See, when you are taking a one decimal number, I am going to write in binary number. See, decimal number. See, decimal number, you take 1. See, what are the place values? You can take place values 1, 2, 4, 8. 1, 2, 4, 8. 1 means what? 1 means what? So you need 1. This is 1. Okay. Now, when you take 2, so I'm going to write all the values here. 1. So you can take 2, 3, 4, 5, 6 like this. See, you write the values here 1, 2, 3, 4, 5, 6. How to write in this number? Look at here. 1 means 1 is needed. Here you put 1. Now 2 means what? 1, 0. Because 2 means what? 1 is needed. Now 3 means what? 1, 1. 4 means what? 4 is needed, right? So 4 is needed. 1, 2 and 1 are not necessary. 5 means what? 4 is required, 1 is required, 2 is not needed. So 1, 0, 1. 6 means what? 4 plus 2, 6, right? 1 plus 1. 0 is 1 is not required, like this. See, for example, you write 7. 7, how will you write? 1, 1, 1. All the numbers are there. See, for example, now how to write 10? How to write 10? 10, 11, 12, 13. See, based on this sequence also, they are going to ask you a few questions. Now base 10. Now base 10 means now you can take here. So 1, 2, 4, 8. These are the place values, right? Now 10 means what? 8 is required. 1 is required. 8 plus 2, 10, right? So 1. Now this is 8 plus 2, 10. So 4 is not required. 1 is not required. 11. 11 means what? 8 is needed. 1 is needed. So 1 is also needed. 1, 0, 1, 1. Because 8 plus 2, 10. 10 plus 1. Now 12 means 8 plus 4, right? So under 8 you put 1, under 4 you put 1. Now 2 and 1 are not necessary. So this is all. 13 means what? 8 plus 4, 12 plus 1. So 1, 1, 0, 1 means 13. Now 14 means what? 8 plus 4, 12, 12 plus 2, 14, right? So 1, 0 is required. Okay. Now 15 means what? All should be 1. So 15 means what? All the numbers should be 1. So hope it is clear. So this is how we can solve the problems. And this sequence is important. See, sometimes in Olympiad, they are going to ask you questions based on this sequence. So that sequence we should identify. So 1, 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 0, 1, 1. So like this. Okay. Now we'll see with the different bases. See, for example, now this is about decimal to binary, binary to decimal. Now let us see decimal to any base, decimal to any other base, any base. Okay. See, for example, you are getting convert 543 base 10 to base 5 system, base 5 system, base 5 system. So base 5 system is nothing but what? You have to divide this number by 5. You have to divide this number by 5. Same way what we have applied in binary system, same way. But here the digit should be from where to where? Base 5 means digit should be from where to where? 0, 1, 2, 3, 4. These are the digits should be there. These are the digits. Now divide this one, 543, right? So 5 ones 5, right? Now 5 0 0. Now 5 8 is 40. What is the remainder here? 3. So now again you divide by 5. So 5 you divide, 5 2s are 10, right? 5 1s 5. Now this is 3. Again you divide by 5. 5 4s are 20. 5 4s are 20. Now remainder is 1. Look at here all these digits. 3 3 4 1. So from bottom to top we should write. So how can I write? I can write 543 base 10 is equal to 4133 in base 5 system. So 4133 in base 5 system. So we can write like this. Now how can we verify whether it is correct or not? So we can verify this one by converting base 5 to base 10 system. Now 4133 base 5, let us convert into base 10 system. So how to convert? You write here the numbers 4133. Now what is the here base value? Is it 5? Base value is 5. What are the place values? This is 5 power 0. This is 5 power 1. This is 5 square. This is 5 power 3. Is it clear? Now 5 power 3 into 4. What is this? Is it 125 into 4 plus 25 into 1 plus 5 into 3 plus 5 into 1. Now simplify 125 into 4. Is it 500 plus 25 into 1? Is it 25? Now this is 15 plus this is 5. So 5 into 3, 15. So 5 power 0. So 5 power 0 is 1. So 1 into 3. So here it should be 3 into 1. Now this is 3. Add all this 500 plus this one 540. So 540 plus 3, 542. See, this is decimal number, right? So this is how we can convert. Any number is given, you have to divide by that base and you should write the remainders from bottom to top. So that is how we'll write. So now for example, if they ask you from any base to any base. So if they ask you convert from base 5 to base 7, like that, if they ask you how to solve the problem. See, for example, convert some number. Let us say 213 base 5 to some number base 6 is given. So first, what you directly we cannot convert any base to any base. What you need to do here is you should convert into decimal number and then you should convert. So how can we write a 213 base 5 in decimal number? See, what are the place values? Is it 5 power 0, 5 power 1, 5 square? So we can write this one as 2 into 5 square plus 1 into 5 plus 3 into 5 power 0. 5 power 0 is nothing but 1. Now 25 into 2, is it 50 plus 5 plus 3? So what is this value? 58. So whether this is correct or not also we can verify. How can we verify? You convert this 58 into base 5 form. How can we convert? So you can divide this 58 by 5. So 58 by 5. See 5 how many times it will go? 5 11 times, right? Remainder is 3. 5 2 times how much? 1. Look at here. 2 1 3 are right. 2 1 3 only we got, right? Look at here. So 2 1 3 in base 5. So you can convert like this. So 2 1 3 here. Here also you are going to get 2 1 3. So here this is 2 1 3. So here also you will get 2 1 3. So look at here. This is 2 1 3 and this is 2 1 3. So now what we are going to do? See, we have converted base 5 system to decimal system. Now we are going to convert this system to in base 6 system. So what is here? Number is 58, right? 58 you divide by 6. How many times it goes? 6 9 times 54. Remainder is 4. Again you divide by 6. 6 1 times 6 and this is 3. So what you can write? 134 base 6. Okay. Now whether it is correct or not also we can verify. How to verify? 134 base 6, right? Now what are the place values of this? Is it 6 power 0? Is it 6 power 1? Is it 6 square? Now 6 square into 1, 36 plus 6 into 3, 18 plus 1 into 4, 4. So 36 plus 8, 44 plus 10, 54 plus 4, 58. See here also 58, here also 58. So like this we can convert any base to any base we can convert. Okay. Any doubts are there here? So I am explaining with 2 to 3 examples. Okay, hope you will understand. Now here one more important point you need to understand. See here, for example, when you take any base, see, let us take for example base 5. Base 5 means what? Digits should be from where to where? 0 2 3 1 4 only. For example, if a number is given other than these digits, okay, that is invalid. See, for example, if you get a number like this 6 7, okay, base 5 is given. See, in base 5 system, 6 and 7 won't come, right? This is invalid. This is not correct. This is invalid. See, for example, if I am writing 1, 2, 3, base 3. See, here the base is 3. So here the base is 3. Base is 3. Digits from where to where? Digits from 0, 1, 2, 3 only. So this is not, this number itself wrong. This number itself wrong. So this is invalid. Okay. So hope it is clear. So now we will solve one small example problem, and then we'll do previous exam questions. Okay, now see one question I'll write 245 base x. See 245 base x, 245 base x plus 162 base x plus 162 base x minus 427 base x minus 427 base x is equal to 0 in some base x is equal to 0 in some base x. Okay, so we have to find the value of x. We have to find the value of x. So how can we find? See, we already know the place values, right? So in some base x, find x there. See, and we have already learned base is, see, the minimum base is 2. Minimum base is 2. So minimum base is 2. So the bases are valid only 2, 3, 4, 5, 6 like this. Okay. If the base, if you get 1, that is invalid. Now 245 base x, what are the place values? Is it x power 0, x power 1, x square? Here also x power 0, x power 1, x square. Here also x power 0, x power 1, x square. Now convert 245. How can we write? 2 into x square plus 4x plus 5 plus 162 means place values 1 into x square plus 6x plus 2 minus of 4 into x square plus 2x plus 7 is equal to 0. Now we have to simplify this. So how to simplify now? So this is a 2x square plus 4x plus 5 plus x square plus 6x plus 2 minus 4x square minus 2x minus 7 is equal to 0. Now add this. So 2x square, 3x square minus 4x square. Is it minus x square? Right. Now look at this 4x, 6x minus 2x. How much you will get? So 10x minus 2x plus 8x. Now this will get cancelled, right? Now look at here 5, 2 minus 7. So that will get cancelled. So x square minus 8x is equal to 0. Now so multiply with or take minus x common, what you will get? X minus x into x minus 8 is equal to 0. So x is equal to 0 or x is equal to 8. So x is equal to 0 is not possible. So the base should be 2, 3, 4 like that. So this is not possible. So what is our answer? Now base x is equal to 8. Okay. And while checking answer, now look at here, when you get answer 8, we should not conclude the problem because we have to check. So here base 8, are the digits lying from 0 to 7 or not? See 2, 4, 5 are less than 8. So okay. Now here also you should verify. So base is 8, 1, 6, 2, right? So less than 8. Okay. Now here base 8. So all the digits are less than 8. So 8 is our correct answer. So like that, even if you get the answer, we have to verify once. So whether it is correct or not, we should verify. Okay. So now like this only one very simple question asked in previous exam, Ioqm. See, now this is the question they asked. See, a number in base 10 is 503. In base B, 305. So we have to find out product of digits of n. Okay. So now how to find out? See, very simple question, this one. a number in base n, 503 in base b. So what does that mean? 503 in base b is equal to, what is the base next one? So 305. 305 in base b plus 2. B plus 2. Now what are the place values? Is it b power 0? This is b power 1. This is b square. What are the place values here? This is b plus 2 whole power 0, which means b plus 2 whole power 0 means 1. Now this place value is b plus 2. Now what are the place value of 3? B plus 2 whole square. Okay. Now you see, now we have to convert this into decimal number system, and then we should write here. So now you can simplify easily here. So how to simplify here? So place value of b. So this is 5b square plus 0 into b, 0, plus 1 into 3, 3 is equal to, now 3 into b plus 2 whole square plus 0 into b plus 2, that is anyway 0. So now this is 5. Now simplify this. 5b square plus 3 is equal to 3 into b square plus 4b plus 4 plus 5. So you can simplify this. 5b square plus 3 is equal to 3b square plus 12b plus 12 plus 5. Okay. Now what you will get from this? So now let us simplify this. 5b square plus 3 is equal to 3b square plus 12b plus 17. Now 5b square minus 3b square, 2b square minus 12b. So 3 minus 17. So minus 14 is equal to 0. Divided by 2, b square minus 6b minus 7 is equal to 0. Now when you factorize this, what you will get? B square minus 7b plus b minus 7 is equal to 0. So you can write this one, b minus 7 into, so b plus 1. B plus 1 is equal to 0. So b is equal to 7 and b is equal to minus 1. See, base, this is not possible. This is not possible. Why? Because base should be minimum value 2, 2, 3, 4 like that. Now look at here. Now we got the base value. What is the base value we got? B7. Now find out the number. See, what is the number? This is the number we have considered. Now n is equal to what? 503 in base b. What is b value? 7. Convert into decimal form. So how can I write? 5 into 7 square plus 0 into 7 power 1 plus 3 into 7 power 0. 7 power 0 is nothing but 1. Now what is this? 5 into 35 plus 3. So what is here? 35 into 5. 5 5 is a 25. 5 3 is a 15, 2. 175. So what is this value? 178. Right? So 150, 21. Now 8, 7, 56. Okay, somewhere we went wrong, I think. Okay, 5b square plus 3. 3 into b plus 2 whole square. Okay, 3b square plus 12b plus 12 plus 5. So here you will get 2b square minus 12b minus 14. So b square minus 1. Okay, b is equal to 7. Now 7 square 49, right? Oh, small mistake. Okay, so 7 square is 49. So you can write here. So 5 into 49 plus this is 1. So 49 into 5, how much? 5 9 is 45. So 245 plus 3. So what you will get? 248. So 248 means what? So now this is the, they are asking. So what are the product of digits now? 248 means, so 64 you will get. So 8 into 4, 32. 32 into 2 is 64 ma. So this is the answer. So what are the product of digits? So they are asking product of digits in this number, 248. 248 means 2 into 4 into 8. 2 into 4, 8. 8 into 8 is what? 64. So this is the answer. Now see, look at here, very simple question which is asked in Ioqm 2022. So previous year question only. See, you can easily solve like 2 marks questions we may get easily. So like this. we can easily solve. So let us solve another question. See, another one simple question. See, look at here. This is consider the equation 1, 2, 3 base 5. 1, 2, 3 base 5 and x8 base y. So we have to find out number of possible solutions for this equation. See, now what we do here is we can easily convert this one. See, how can we write 1, 2, 3 base 5 is equal to x8 base 5. So 1, 2, 3 base 5, how will you write here? So the place values you should write. So this is 25, this is 5, and this is 1, right? So how can I write here? So you can write 25 plus 10 plus, so this is what, 3. So is equal to, this is what, xy plus y power 0, 8. So 25 plus 10, 35. So 38 is equal to what? Xy plus 8. So what is the xy value? Xy is 30. Now very important point here is, look at here, here base is 5. Digits are 1, 2, 3 only. This is valid. Look at here, here the base is y. Here the base is y. And what about x? This is a 2-digit number. X should be from what? 0, 1, 2, 3 and so on up to when? It should be y minus 1. So x less than y should be there. Okay, and x is not equal to 0. Why? Because this is a 2-digit number, right? This is a 2-digit number and x cannot be 0, x less than y. So like that we have to simply split this one, xy. So xy, how can we write? X1 y15. Can we write like this? Yeah, this is possible because x less than y. Now x2, what about 130, 215. So 130, now 215. So x less than y. Now what about next one? 310, 310, x less than y. This is possible, right? Now 4 does not divide 30. So 5 and 6. 5 and 6. Okay, now 5 less than 6. Okay, now 5 less than 6. So possible. So these are the possible solutions. So but 5 less than 6. Look at here, but 5 less than 6 is not possible. Why? Because look at here, here if you take x8 base 6, base 6. Look at here, here already digit 8, right? So then base cannot be 6. So this will not satisfy. Hope it is clear. Because even if you take x less than y, because when you take y10, look at here, when you take y10, no problem. See, when we consider base y as a 10, because digit 8. So 8 is a digit in base 10 system. You can take base 15 also. You can take base 30 also. So but y should be what? Y should be greater than 9. Y should be greater than 9. So this is again a very important point. So y should be greater than 9. Greater than, y is greater than or equal to 9. So y can be 9. So here y is 6, right? So this is not possible. So how many possible solutions are there? Only 3 solutions are there. Because 5 into 6 is not possible. 5 less than 6 only. But when you take y is equal to 6 here, x8 base 6, x8 base 6 is invalid. Why? Because 8 cannot be in a base 6 system. A digit 8 is not possible in base 6 system. Okay. So hope it is clear. So now we will solve another PRMO question. So our See, this is the question now which we are going to solve. This solved in PRMO 2018. See, this is the question they asked in PRMO 2018. See, look at here. This was the question they asked into PRMO 2018. Okay. Now look at here. 166 and 56 is equal to 8590. This is not a decimal number system. You can clearly understand, right? Definitely B is not 10. See, because 6 into 6 how much? 36. Unity digit should be 6. See, you can clearly understand that this is not a base 10 system. And they have given hint here. What is that? B is greater than or equal to 10. And they gave points here also. 165890 are digits in base B. So how to write now? Now this is one you should convert like this. 166 into base B into 56 in base B is equal to 8590 in base B. Just to convert now, what is this? B square plus 6B plus 6 into what is this here? 5B plus 6 is equal to, you will get this. So what is this? 8 times B power 3. Now 5 times B square plus 9B. So you will get like this. Now you need to simplify. Now B square into 5B, 5B power 3 plus B square into 6, 6B square plus 6 into 5, 30B square plus 36B plus 30B plus 36 is equal to what? 8B power 3 plus 5B square plus 9B. Now look at here, ma. Now when you simplify this, 5B power 3, 8B power 3. So bring it to one side. What do you get here? 3B power 3, right? Now what is this here? You can clearly see here 36B square, 36B square and 5B square, right? Now what do you get here? 5 minus 36. So is it minus 31B square? Next, 66B, 9 minus 66B. Is it minus 57B? And minus 36 is equal to 0. See, they have given already B is greater than or equal to 10. And you can also identify, or they don't need to mention also. You can understand easily. Here digit 9 is there. Sometimes they won't mention like this. Here digit 9 is there. Digit 9 is there. So what do you understand by that? Definitely base should be more than 10, right? 10 or more than 10. So now look at here. Now this is a cubic equation we have to solve. See now 10 anyway it won't satisfy. So very nearest only they will give. You can check for 11 and 12. So you can substitute B is equal to 11. Okay, and you can verify. It will take just calculation part you can do. Otherwise, if you know synthetic division, you can do base 11. You can take how to solve in synthetic division. So B power 3, 3. So minus 31, minus 31. So what about this? Minus 57, minus 36. See, look at here. This is 0. So 3 times 1, 33. You will get 2. 2 into 11, 22 minus 35. Minus 35 into 11, it is more than this. Anyway, you won't get 0 here. Not necessary. Now divide by 12. So write B power 3 coefficient 3. B square coefficient minus 31. This is minus 57, minus 36. So here you put 0, 3, 12, 3 is how much? 36. So it is 5. So here 60. Here you will get 3. 3 times 12, 36. Here you are getting 0. So now B is equal to 12 will satisfy, right? Now you can write B is equal to 12. Now this one you can write a quadratic equation. What about this? This is B square coefficient, right? 3B square plus 5B plus 3. This is equal to 0. Now check here how to find roots. Check discriminant here. So B square minus 4AC. Discriminant means what? X square coefficient is how much here? 5. So 5 square minus 4 into 3 into 3. So 25 minus 36. So this is negative value 11. Negative 11. So here you won't get real roots. No real roots for this. No real roots for this. So only one value possible. That is what? only b is equal to 12 is possible. Okay, so hope it is clear. So this is these are the few questions. So in next class we'll see some more problems. Okay. Okay, thank you everyone for joining the math session. Okay, thank you, sir. We are going to wind up.
Okay, sir. Okay, thank you.
Okay, thank you.